Today, I'm going to talk to you about streamlined source control using embedded Git on InterSystems products. My name is Pravin Barton. I'm a principal developer on the application services team here at InterSystems. So, brief agenda today. First, I'd like to give some really broad background about source control, why you want it, and what's different about InterSystems and source control. Second, I'd like to give an introduction to Embedded Git, which is a project I'm a primary developer on. Many of you already use, and some of you hopefully will use. And third, I'd like to give a set of updates about Embedded Git, the state of Embedded Git in 2025. I or other people have presented on Embedded Git in past years. You might know it as Git source control. We changed up the name a little bit because Git source control is a little redundant, confusing. Embedded Git, I think, is better. But there have been some changes over the past year, and I'd like to go into them. So first of all, why use source control at all? Source control is very important if you want to have a change history. You want to know exactly what has changed in your code base, in your system, why it changed, when did it change, who did it, who can I blame, who deserves the credit, etc. Your ideal is that every change is discoverable. You know what it is. It's repeatable in case you need to do it again. You can look at an example from the past. And very importantly, it's revertible. If I do something that breaks something, people are yelling at me, I can just undo it really quick. Source control is also really important when you're collaborating with a team of developers. As soon as you have more than just one person writing code or creating technical stuff in your instance, you really need source control. And often source control is the basis of deployment strategies. If you're deploying code into a production instance, for example, often your source control repository is the basis for what you're building and deploying. All right, so what is different about source control with InterSystems? As a software developer, if I'm just building like a JavaScript app or something, I'm usually used to editing a bunch of text files on a directory in my computer. I'm used to just initializing that directory as a Git repository. I use the Git command line to track changes to those files. Iris can be a little different, and that's because Iris code lives in a database. And when I say code here, I mean code in a very broad sense. This might be things that you don't even think of as code because you're just building it in a low-code, no-code GUI editor. Something like the Iris interoperability portal, the Health Connect Cloud portal, that sort of stuff. All right, so code lives in a database. Traditionally, you edit it with server-side editing. That means you have something that's connecting to the database and making your changes directly there. Traditionally, this has been Iris Studio or Cache Studio that uses server-side editing only. More recently, we've switched to VS Code with our own ObjectScript extensions that supports that same server-side editing model. It also supports something called client-side editing, which is more like you're just editing files in a repository and then saving it, pushes it into the database. And then there's also all this stuff in the management portal. Those like low-code, no-code UIs I was talking about where you can drag and drop to build mapping, stuff like that. That, of course, is server-side editing because you're using a UI that's powered by the server. Examples of that are interoperability portals, business intelligence, etc. So code existing in the database might sound strange if you're coming from one perspective, but it's also very common if you're working with databases. Think about your life as a SQL developer. If you're administering a database with SQL, you're probably running a bunch of like DDL and SQL statements that create things like tables and views. But those statements themselves, you need to do something else to make sure that those items are source controlled. All right. So what is that something else that allows you to use source control with the server-side editing? This is something called a Studio source control extension. Naming is a little misleading. It works in both Studio, it works in VS Code as long as you're using that server-side editing model, and it works on those management portal code builder UIs. What do these extensions do? They will synchronize documents in the database with files in some working directory. You'll sometimes hear these called source control hooks because they hook into actions that your editors are taking. Like you're adding a new file, you're saving a file, you're compiling. And what they do is export that item from the database into your source control repository. Usually, source control extensions also provide you with a simple user interface for doing certain operations like submitting a change, pushing it somewhere else, etc. So there are many options for Studio source control extensions compatible with Iris. Built into the product, there's one for Perforce, which is another source control, source code management solution. You can even build your own Studio source control extension. There's some documentation about how to do that. There are a number of tools on the Open Exchange. If you go there and search for source control, you'll see a number of like either proprietary or open source tools like George James Software, Embedded Git. And hey, number 4 is Embedded Git, which is what I'm here to talk about. All right, so what is Embedded Git? This is an extension that provides you with embedded source control using Git for InterSystems products. This is an open source project. It's maintained by the application services team within InterSystems. And there's the handy link for it. It has a GitHub repository that you can see documentation and install it from. So a sidebar, what is application services? We are a team inside InterSystems that manages a very large suite of internal applications, including one called CCR, which is another change management solution used by a ton of systems all across the world on top of Perforce. We wanted to take our expertise or our knowledge in building these source code management solutions and provide something to customers so they can use Git with it. So that's why we're in charge of Git source control. But it's a community project, and we very much welcome pull requests from the community. So check it out. All right, a little more about Git. Say you're using source control with Git, and you're using an IPM package. IPM package, that might not mean much to some of you. That's okay, you can just ignore this. But IPM is the InterSystems package manager, and it allows you to define all of the locations of the resources in your application, in your service, solution, whatever, using a file called module.xml. This is basically a manifest of all of the resources associated with your package. So it kind of looks like this. This is from the object script template ZPM package, which you can find on the InterSystems community GitHub. If you have this module.xml, then that tells us exactly where to export your items after you edit them. So Embedded Git will look at your module.xml, it'll hook into your editors, and it'll export items after you save them into the right place. In addition to export, Embedded Git handles locking. So say you have a shared development environment. Say there's one namespace where everybody is logging in to make development changes. This is not like my ideal experience as a developer, but it's often the easiest, most friction-free way for people, especially in the healthcare spaces, to set up development servers. Just because setting up like an individual development environment for every person can be a bit of a headache. But say you have this shared environment, you need some sort of locking. I need to be able to edit something, Hannah needs to be able to edit something, and we need to not be able to edit the same thing, because then we'll edit the same thing, we'll overwrite each other's changes, we'll get confused, who knows whose is whose. All right, so Git is not something that provides you with locking because it's more of a distributed model. Embedded Git provides you with a layer on top of it that allows you to add locking. Okay, so you're not using IPM. In that case, we don't have this module XML telling us where in the repository all of your items live. So instead, Embedded Git has a settings page. The settings include a set of mappings which define the location of the resources in your Git repository. It comes with a set of defaults, which are kind of basic. You can add onto those and customize them as you need. So for example, here we say that our classes live under a subdirectory called src. unless they're a unit test class, and in that case, they live under a separate subdirectory named test. And then we have other mappings for like system defaults, for HL7, for inc routines, etc. All right, so in addition to that export and locking, Embedded Git provides you with a web UI. This is like a web page built into the extension that you can access through the system management portal that allows you to do source control operations. I'll give a more extensive tour a little later in the presentation, but for now, know that you can commit changes, you can discard, you can stash changes, you can apply them from the stash, you can restore discarded files, you can manage your Git branches, and you can push and pull from your Git remotes, because you probably have a remote set up so you can actually have other people looking at your code. All right, BYO, branching model. That stands for bring your own, because we don't provide you with a default branching model in Git. This is gonna differ from organization to organization and for the needs of your project. I've provided diagrams of a couple of examples. The one on the left, I guess it's the right for you because we're facing opposite directions. No, that doesn't make sense. Anyway, the first one is a very simple branching model, sometimes called the GitHub flow. It's great in a lot of ways. You basically have one master branch, or main branch, that's a trunk. And whenever you need to make a change, you'll create a new branch off of that. So you'll have a new branch for a bug fix. You'll have a new branch for a feature. All of your commits as a developer will go into that feature branch. And when you're ready to have that looked at by other people, you'll create a request to merge from your feature branch into your main branch. Other people will look at your changes. They'll say, no, you have to do more work. Or they'll say, yes, it's ready to be merged. And when it's ready to be merged, it goes directly into your main branch. This is the branching model we use for Embedded Git itself. It's really useful if you have a model where like you're making a bunch of changes, you're merging them into your main branch when they're ready, and then at a certain point you say, okay, we're good, we're gonna cut a release based on the state of main branch at this time. We're gonna distribute that release through however we distribute it. And then every future feature or bug fix will just go on the next release version. It's also nice if you're like building something like a web page where you're constantly making little changes and merging them into your main branch and you want to immediately deploy them. It can be useful with complex applications if you're like deploying all of the time, but hiding features behind feature flags so they only get rolled out based on like some dynamic thing in the code. Since it's such a simple merge and branching model, you avoid merge conflicts very well. I would say that second example probably doesn't describe most of the people in this room. That's not very common for our technology. So the second example here is a more common branching strategy. This is the one that we actually prescribe for users of InterSystems Cloud Services. If you look up using GitLab for InterSystems Cloud Services, there's some really great documentation that goes into detail on this branching strategy and what the development workflow is for that. There's even an online course with videos. It's beautiful. But this branching strategy is very similar to the first one, except it adds 2 more branches. So you have your live branch, which is the equivalent of master in this first one. And then you also have a test branch and a dev branch. You have separate environments that are based off of the test branch and the dev branch. Before merging into live, you merge into dev, and you merge into test. You get it approved at every step. That allows you to test each of your changes in a separate like testing environment in combination with any other changes that are already there. All right, now we get into the updates portion of this presentation. Embedded Git in 2025. Can't believe that's the year number. Time flies. All right, first important thing. If you last installed Embedded Git at this time in 2024, our user interface looked very different. We've made some massive improvements, especially last summer. So our old user interface was more like you had a separate pane for staging changes. You could add stuff to be staged and then from there commit it. That was not like a very good, I mean, it's a great concept in the Git command line. I don't find it very helpful in a web UI context. So instead, we just have this list of files, which is everything that's changed in the repository, everything you've edited. You have a checkbox. You can check what you want. You can enter a commit message, even add an additional details that gets included in the message, and commit those. This is very similar to if you've ever used GitHub Desktop. I'm not going to say we cribbed their UI. We just took a little bit of inspiration from it. I also wanted to call out that you can click on any item you have edited, and you can see the diff for it. Like this is a new file. You can see on the right all this stuff. On the left, there's nothing. But if it was just an edit of an existing file, you can see exactly what changed in a text format. All right, in addition to viewing the workspace with all of your active changes, you can also view the stash. So a very common workflow when you're using Git is I get interrupted in the middle of something. Say I'm working on a feature that I hope to release some point in the next month, and now suddenly there's an urgent bug fix that I need to get to before then. What I'm going to do is stash all of my changes, switch to a new branch for my bug fix, do all my work for that, push it forward, my users are happy, and then I go back to my old branch for the feature, unstash my changes. Unstash is not the real word, but we have options you can see to apply or pop from the stash here. So that lets me very easily save my changes, bring them back later. All right, this is something that's not part of Git, but we found important to put in our web UI as well. A section for discarded files. It's got that nice recycle bin icon that you'll recognize from the trash on your computer. Say you've added a new class, then you go into the workspace and you see you have it, you decide, oh, I don't want to do that anymore, you revert it. Not only does that class get discarded from the Git repository, it also gets deleted from Iris. Because remember, Git source control, embedded Git is very good at synchronizing your Iris instance, the code in your database, with your Git repository, the code on the file system. This can be dangerous if you discard something and you're like, oh, I didn't actually want to do that. Did I really lose my days of work? Now you can look in the discarded files section and view a list of everything that you have discarded with an option to restore them back into your Git repository, back into your Iris instance. So you can check them in or continue work. All right, at the very bottom left-hand corner, you'll see a change context menu item. What is a context? So a context in Git source control or embedded Git is basically a part of Iris that is talking to a specific Git repository. So assuming that a normal setup, every namespace will have its own Git repository. Each namespace will be a separate context. But say you're also working on IPM packages. An IPM package will have its own Git repository. It'll be its own context. So you can view a list of all of the contexts active for your instance here and easily switch between them so you can perform Git operations through the UI for each of them. And finally, I think this is the final one. This is a really handy option. Also on the bottom left of the Git UI, there's an option to download a VS Code workspace. If you've ever switched from Studio to VS Code, you might have run into a little friction about like, what should my workspace in VS Code look like? I think the extensions do a great job of making it easy to just click through and define like your server connection, your namespace, what sort of code you want to edit for a server-side editing connection. But it would be pretty nice if I could just do that with one click. That's what Embedded Git does with this code workspace option. It allows you to download a workspace file. You open it up with VS Code, and assuming you have the extensions installed, you could immediately start editing code on this instance. So you'll see, here's the example of a VS Code workspace. It creates a server definition with like a unique GUID. It tells you what the web server and port, et cetera, is, and just gives you a folder where you can edit code in that namespace. All right. Yeah, that was not the final one. Oh, that was the final part of the UI tour. Now we're getting into some other cool stuff. Basic mode. I don't know if any of you managed to catch my tech exchange. That would have been Monday on Health Connect Cloud with GitLab with Embedded Git. But basic mode is a mode we added to Embedded Git to make it really easy for people who don't really care about Git as a technology, who don't really want to know about the gory internals, to use Git, use source control with that recommended cloud services branching model very easily. So there's a number of operations that you're usually doing in Git if you're following this branching model, like you're constantly pulling from your remote, you're merging like from your live branch into your own feature branch, et cetera, and then you're committing your own changes, pushing them up. Basic mode encapsulates all of that into one option called sync. Okay, it's 2 steps actually. When I start working on something, I'm gonna create a branch, and from then on, I'm just gonna sync. And that's gonna do my commits for me. It'll let me enter a commit message, and that'll push it up to your remote, et cetera. I mentioned earlier, the documentation on using GitLab and Git with InterSystems Cloud Services with very clear steps on using basic modes. Yeah. I would definitely recommend it to not just cloud services users, but anybody who is using that branching model and doesn't want your interface developers to have to know a bunch of gory details about Git. All right, another big improvement is called production decomposition. This is important for interoperability with productions. So what's the problem with interop productions and source control? The production configuration is a very common bottleneck when you're in an interoperability environment and you want to start using source control. That's because the production configuration is a giant file with a ton of different items in it. It has essentially a class definition with an XML block with every single item in your production. Say you have dozens or hundreds of interfaces, that'll be dozens or hundreds of items. So that means that everybody who is working on a new interface in your system will be editing the same production. Say you have a shared environment, a shared namespace. I am working on a new interface, I edit the production, now it's locked, nobody else can do anything. Even say we have individual developer environments, like I'm working on my namespace, another person is working on their own namespace. Whenever one of us adds a new item to the production, we'll get a constant merge conflicts in Git as these items are added to the bottom of that XML. They kind of overlap with each other. It's kind of a mess. All right, how do we solve this? The solution is to represent our production configuration as an individual file for each item instead of one big file for all of the items. We already have a format that we can use for these item files. It's called PTD. It stands for Project Text Document. And this is the format for production items that is used by the deployment manager. So if you've ever said, export these items from one namespace, import them into the other namespace, that's the underlying data format. So it's kind of a well-supported part of Iris interoperability. So production decomposition means we're representing our production as a bunch of PTD items instead of one big file. This is supported by both Embedded Git, which is what I'm talking about, and CCR, which is another change control option maintained by our team. What does this mean? So if I have a shared environment where everybody's editing in the same namespace, my editing items will lock only the individual item that I have modified. I can modify my item A, Hannah can modify her item B, and we won't lock each other out. Say we have a better setup where we each have individual namespaces, that isn't really an issue. But it's still really helpful because it avoids those merge conflicts. You'll only have a merge conflict in this case if the same item is actually being modified, which is when you need to have a merge conflict because the two of us need to talk and fight it out in the arena of who is right. All right, I'm gonna do, yesterday I did a more full demo of production decomposition, how to turn it on, what it looks like. I'm gonna play a real small snippet from that video just to show off how easy it is to adopt production decomposition. So I'm in the interoperability editor. I have this giant production. Okay, it's just a tiny demo production, but use the power of imagination, I guess. I'm gonna go into my Git project settings. Oh, there's that mappings I talked about earlier. But there's also this checkbox that called Decompose Productions. I'm gonna turn that on and save my settings. All right, now I've changed the setting, but I haven't done anything with the Git repository, except you'll see this setting is changed in my settings file. What I need to do now is re-export my production in the new format. So under the source control menus, there's a new item called Export Production. I'm gonna select that. What that is doing behind the scenes is exporting a new file, a PTD file for every single item in the project, in the production, and then deleting my class file, so it's no longer in source control at all. You'll see a bunch of output in our source control output saying it did exactly that. And now I want to go check that in, commit it to my branch. Well, first I'll show off, this is what a PTD file looks like. It's kind of slightly ugly XML, but it's still, well, you can see exactly what is in the settings. You can see changes, etc. I'll commit it. And there we go. My branch, my namespace is decomposed. It's under the ground, decomposing. In reality, it's a little more complicated because this is just my branch, my namespace. I'll also want to push that up to my remotes. I'll want to make sure that nobody else is changing stuff at the same time, because you'll get a bunch of merge conflicts if somebody has an in-progress change and I just totally changed the representation of what is being changed. So we recommend change freeze before doing that. Look on our GitHub repository. There's a document with some abstract steps about how to apply production decomposition. All right. Last item I wanted to talk about that we've added, also relating to interoperability. This is related to system default settings. So say you have a test environment, you have a production environment, you want certain settings on those productions to be different. For example, your test server wants to be talking to some other test server. So your host name or your port will be different on certain operations. How do you do that when your production is in source control? The way to do that is to move those settings that need to be different out of the production and into your system default settings. This is a long-standing Iris interop thing. What's new for Embedded Git is the ability to source control your system default settings. There's a new item in our source control menu that allows you to export your system default settings. What you'll want to do is define a mapping. I don't know why I'm pointing at my screen. That isn't helpful for you. But yeah, define a mapping for ESD items. You'll give that a directory in the Git repository that you want your ESD items to live in. ESD just stands for Ensemble System Defaults. It's the system default settings file. Where was I? All right, so you want to map these ESD files to an environment-specific folder in the repo. Environment-specific means that you're going to be including this magic token, env in angle brackets, in your mapping directory, and that will be expanded to the environment name of your instance. That's another setting you can change in Embedded Git. It's also just an Iris basic setting called system mode. So you'll have a development environment, a test environment, production, etc. And that means your ESD files for each of these environments will exist in a different folder. They won't collide with each other. All right, that's my update. From here, what can you do if you want to stay involved with Embedded Git? So first off, here's our Git repository, our GitHub repository. Git source control is the name. It's the old name, but it's still in the URL. Please click follow if you're on GitHub and use that to stay up to date with our releases, stuff like that. And we also have weekly user group meetings. These are often like whoever has a question or an issue with embedded Git, whether they're internal or a customer or some other person can drop in as they need. These are weekly on Wednesday mornings, I believe. If you want to join these meetings, email me, firstname.lastname@intersystems.com. Whoop. Sign up for our early access programs, and please give us feedback. I'll stay on here for the QR code, and now I'd love to take any questions that people have. Yeah, good question. So the question is, the embedded Git repository stored within Iris, or is it connected to a third party? So if you're developing a project with embedded Git, the repository is just gonna live on your file system somewhere that's accessible from the Iris instance. If you're using Git for a full development workflow, you're also going to be using what's called a Git remote. There are a number of these, like GitHub and GitLab are third-party services that have been used very successfully for storing source code with Git. Yeah, great question. So how does embedded Git react to changes made in a Git remote, like editing files directly in GitLab? There's an option in the source control menu that embedded Git provides you called pull, that does a Git pull where it'll sync down any changes from your GitLab remote into the local repository. And embedded Git is smart enough to see exactly what changed when you did a Git pull and load anything that needs to be loaded into your Iris namespace. It even will delete items for you if they've been deleted from the remote. So the question was, when I'm making changes, they're not just code changes a lot of the times, they're configuration changes that really amount to setting globals. Can I store my globals in my Git repository? The answer to storing globals specifically is no, we wouldn't want data to be in your Git repository, but it's absolutely possible to automate your configuration changes with routines or class methods, which will do things like configure an OAuth client or set some system setting or set up a CSP web application. And there's a way to extend embedded Git so it'll automatically run that automation when certain things have changed in the Git repository. The keyword for that is pull event handler, and there's some explanation of how to do that on the documentation. Yeah, and just for the sake of the recording, summarize that as if there's configuration items that really should be source controlled, treated as a source controlled item in the repository, bug us about it because we should do that. Good question. How do I upgrade to the latest version of embedded Git? So if you're using InterSystems Package Manager to install packages, then you can run an IPM command. You can say zpm install git source control and give it the latest version. There's also some documentation about how to do this if your network segment won't allow you to access like the IPM registry. You can download a file onto your file system and then just load it into Iris. And there's some steps how to do that on the README in the GitHub repository. All right, well, thank you all again for showing up.